So let us now see these few interrelated terms: alpha, beta, significance level, confidence interval, and margin of error. So here is the table that you must have studied during screening or when you calculated specificity, sensitivity, etc. So here D is for disease and T is for test. So if a patient is actually having a disease, then test should come as positive. Okay. So let's say you are conducting this under a research for which you will have a null hypothesis. Now we discussed before that null hypothesis negates any possibility of having a positive outcome. So if you are conducting a research to detect a disease, null hypothesis would be that there are no disease. So this is null hypothesis true, and this would be if null hypothesis is false. This means that null hypothesis is false because disease was present. Same way for tests. Now if a test is negative, it means that it is supporting null hypothesis, which means it is accepting it. So accepted, null hypothesis accepted, and if it is positive, then it is rejecting it. Now if a disease is there, test should come positive, so this would be a correct choice. If there is no disease, then test should come negative, this is also correct. But if there is a disease, then test should not come negative, it is called falsely negative. And if there is no disease, test should not come positive, it is called false positive. Now this false positive is alpha or type 1 error, and this false negative is beta or type 2 error. Now it is not only confined to tests and diseases. In different kind of research there are different hypotheses, and for it you can bend it to make sense of it with regards to that research hypothesis. So here is a beta version which is clearer, you can get a screenshot. Now if you are given alpha level of 0.05 or 0. Which is also as 5%. So that means a researcher is willing to take the risk to be wrong. That means this 5% portion is the portion that researcher did not expect when he started the study. Expect in terms of null hypothesis. If you remember, null hypothesis is that there are no positive results. The test will not yield any positive results. So if 5% time researcher is wrong, that means null hypothesis was proven wrong and there were actually positive results. So this is an arbitrary limit, and for one tail test this is called as alpha. Now remaining portion is called confidence interval, 95%, because in this arena researcher is sure that population mean will lie 95% of the time within these limits, and significance level is this 5%, which is also alpha, because if value comes in this part, then only it is considered as significant, otherwise it is non-significant. Why? Because it is normal value, and normal is never significant. Now two-tailed test. So Z tests are most of the time Z tests are two-tailed tests and two-tailed T tests. For them, now if researcher says that he wants to keep alpha at 5% level, now it has to be divided between these two sides. It can be within lower tail or upper tail. So it has to be alpha by 2, alpha by 2, because overall he is taking risk of getting wrong 5% time. Now he can be wrong by having a result that is very high than the expected value or very low as compared to expected value. So alpha by 2, which will be 2.5%, is divided as both sides. Alpha is divided into both sides. Now for this is confidence interval. This would be mean. This is mean, right? Now there are few terms that you need to remember. This was confidence interval, this area and this area. Both of these are called rejection area. You will reject null hypothesis if it comes under here. Now if you see this area and this area, they are equal, they are equidistant from mean. They individually are called MOE or margin of error.